Okay, so if I looked at this right here, and remember the first thing we do is we kind of estimate how many times will like 30 go into 40, and we see those are higher, so like more like 40 into 50. But still, we kind of estimate what that's going to look like, right? And so then we say, okay, well, if I divide, that's going to be 1 time. And then the next step is I do what?
Subtraction.
No, I don't.
You multiply 1 times 37.
I multiply 1 times 37. There we go. So we multiply 1 times 37. And now the next step is what? Subtract. There we go. So I put the subtraction sign and I draw this line, right?
Yep.
Okay. And then I subtract and I find the answer is 12. And now I do what?
You add.
No, I don't add. I bring down. Okay. It is like it's adding a digit, but it's bringing it down. And now I do what? I go back and I repeat the whole thing. How many times does 37 go into 125? Well, it's almost 40. If I count by 40s, I would go 40, 80, 120. So we're going to say 3. But then I actually have to do the multiplying, okay? So that would be 21, and that would be 9 plus 2 is 11. And now I subtract, okay? And I get 14. All right, so 1, 4, and then I bring down this last digit, which is a 2. Now, how many times is 37 going to go into 140? Well, 3 times gave me 111. So if I add another 37, that would be 148. So will that work?
No.
No. So it's still just going to be 3, which gave me the 111. Okay. And then I subtract, and I have 31 as a remainder. And now what do I do with the remainder? Bring it up here, and you do what? You put 31, or not plus,
37.
sorry. That's what we will be doing. 31 over
37.
whatever this is over here. Okay, so it's the same idea, only it's complicated.
Love to hear it.
So, first of all, we're going to write them in order. Like if I had told you this number was 52, 900, and 4,000, or 52, 4,000, and 900, you would have reordered those correctly, right? Okay, so if you look at example 3, just follow along. I don't want you to worry about writing it down right now. We're going to put them in order from the highest variable, or highest degree polynomial, which is a cube, and then minus x squared plus 5x, and then plus 2. And then on the outside of that, we want to have this term where it says x minus 4, okay? So we don't want the minus 4 first. Again, highest degree first and working your way down. So we're going to do the same thing. We're going to say how many times, we're going to look at the dividing. Just like we said, how many times does this go in? How many times will x go into 5x cubed? In other words, here's how you find the answer. Divide. So that gives you what?
5x squared.
5x squared. That's our answer there, okay? Now, the whole thing doesn't actually go here. It actually is going to go here.
The first spot.
Okay, into the, not the first spot, just like here, 37 didn't go into 4, did it?
Why can't x go into a 3?
Because we're dividing by an x in essence, basically, okay? All right, now I multiply. So 5x squared times x gives me 5x cubed, and then 5x squared times negative 4 gives me negative 20x squared. What's the next step? After multiplying is what?
Subtract.
Okay, so if I'm subtracting this entire thing here, what happens to the sign of both of these numbers? They both change, okay? This is where it's easy to make a mistake. So what I like to do is I like to change my sign here. That becomes a negative, and then that will become a positive before I draw this bar. It's kind of a mental break. Change the signs, then draw the bar to subtract. Okay? Now, these should always cancel because we purposely picked that. And then these should always be the same degree polynomial. So we should have x squareds, both, okay? If it's not an x squared, or if they're not the same, it doesn't have to be an x squared. If it's not the same, then you need to go back and kind of like rethink something because something's not working right. So they all should, like, what you're trying to add here should be able to be added. All right, and then the next step is what? We bring down the next term. Now, how many times does x divide out of 18x squared? What do I have there? 18x, right. Again, 18x squared divided by x. That's all we're doing there, okay? And it's positive, so this will be plus 18x, multiply, that'll be 18x squared. And then 18x times negative 4, that's going to give me negative 72x. That would be the 2. I need to write the 7 first. I hope she gets back with coffee soon. There we go. Okay, now I'm going to draw the subtraction bar, right? No, first I'm going to do what 2 things?
Change your
I'm going
sign.
to change the 2 signs. So I'm going to make this minus, and that's going to make that into a plus. Now I'll subtract, okay? So those cancel, and this becomes 77x. Bring down the next term, which is a plus 2. Okay, and now I divide again. How many times does x divide out of 77x? So our answer would be 77 there. So 77x. Somebody want to tell me what that is? 8, carry the 2. Another 20, 308. 308. There we go. And then I change the signs before we subtract. Subtracting is changing the signs. And that gives me then a remainder of 310. Now where does the remainder go? Plus 310 over x minus 4. Okay, you sure this is still your favorite thing? Okay, all right.
Well, you did it last year, so she probably does know.
There is a bit of this that is kind of like feels good when you see like all the x squareds are lined up neatly, all your x's are lined up there, and all your numbers are lined up there, okay? If you keep it all nice and lined up, yes, some of y'all are going, I can't write that neatly. If you can write in a line, then it really does, like there's a sense where it's like, oh, this is kind of satisfying, like it works, right? Okay, so maybe that's why, like maybe you like the satisfaction of it working. Okay, so let's look at another one. Look at example 16.4 at the bottom of your page there. Do y'all see that one?
Yep.
Okay, so I've got negative 6 plus x cubed. That's interesting because we talked about writing in descending order, right? So I need to start with that x cubed, and then what do I write after that?
You're gonna write 0x squared.
Okay, if I told you your number to divide was like 5,004, would you write 54?
No.
No, because what? There's a hundreds place and there's a tens place, right?
Yeah.
Okay, so the same thing is true here. There's an x squared term and there's an x term and then there's the numeric term, okay? So I have to include all those, and those have zeros. So plus 0x squared plus 0x, and then we put our minus 6. And then again, what we're dividing by, the book just loves to see if it can trick you, I guess, and they just wrote it backwards. But it's x minus 2. They wrote negative 2 plus x, whatever. Okay, we can handle that. We're way smarter than that. All right, so we're dividing x cubed by x minus 2. So can we divide both of those into this term right here? No, that's basically a 0. But can we divide into both of these things? Yes. So x cubed, we can divide by x, and that's going to give us what? X squared, right? So x squared, that gives us x cubed, and then minus 2x squared. What do I do next? Before I draw the bar, I change the signs, right? Right? Minus and plus. There we go. Those cancel, and this gives me 2x squared, and then I bring down that 0x. Now, how many times does x go into 2x squared? It's going to give me, we're just going to take away one of the x's. That's going to give me just 2x. Multiply that out. 2x squared minus 4x. Now I do what?
You have to
Change the sign. Change the sign. There we go. All right. Gives me 4x. Bring this down. And then I say, how many times can x go into 4x? And that's what?
4 times.
4 times. Thank you. And that gives me 4x squared, x minus 8. Change the signs. And that gives me a 2. Where does the 2 go?
Remainder.
Like, I honestly think, how many times do you even get to just write remainders anymore? You're so used to having to, keep going and make it a decimal that I think y'all forget that that's just the simple, oh, we just read it as a remainder. Okay, now, I'm going to teach you something that's not in the book. I want you to follow along and just watch this time. And then the next time, I want you to, take notes. But I want you just to follow along here, okay? Now, it's a different way of dividing. and I'm gonna draw like an upside down division, and I need to have room for
This is what
two
we
sets of numbers here. And I'm gonna put the coefficients only. So what would be the
7.
coefficient here?
1.
1, 0, 0,
Yes.
negative 6.
These are
One.
much better.
0, 0, negative 6. And then every time when we were dividing, what did we keep doing? Changing the sign, right?
Mhm.
So instead of calling that a negative 2, I'm going to call that a positive 2. Okay? And then what happens the first time, really? Since this goes like this, what happens? We just bring this down, right?
Yeah.
1. And now, every time after this, I'm going to multiply. So I'm going to have this. I bring this down. I multiply these, 2. And then I add those down, 2. And then I multiply again, 4. And then I bring these down, 4. And then I multiply again, 8. And then I bring that down. Now, I have to go back and fill these in. Since I started with an x cubed, my answers are gonna start 1 below that. So this is an x squared. This was positive x, positive 4, and then plus, and then that's where our remainder term goes.
What is this called again?
Division.
Isn't it?
Like, Mr. Blankenship called this something else because we had extra time after our book last year, so we
Uh-huh.
did these.
Yeah. So,
Yes, I think that's what it is. Is it synthetic division?
yeah, maybe that's what it's called. Yeah, maybe so.
It
Maybe
had
so.
some sort
Okay,
of
good
fancy
question.
name.
Yeah, maybe that's it. Okay, so let's do one this way. Okay, let's all do one. So you guys get a piece of paper, and we're actually going to do the practice one. The practice problem, we're going to do it this way right here. So what you do is hang on, let me draw them across here so you see this. This is how this works. When you go down, it makes a plus sign. When you go sideways, that kind of makes an X, right? You see that?
Yeah.
So you add down, then you multiply. That makes like an X, right? See my little line? It makes like an X to over here. Then you add down. If we put little arrows, maybe that helps. Down, over, down. So every time we're going down, we're adding. Every time we're going sideways, we're multiplying again. So add down, multiply. Add down, multiply. Down, over. Okay? So that's the kind of the method there. All right, so you're doing the practice problem. So what number do you put on the outside of your little square thing?
-3.
Oh, careful. We change the sign. So positive 3.
Oh.
Positive 3. And now we need these terms. Which is the highest term? We have an x cubed, right? So that's going to be 4. And then what's our x squared term?
3.
Negative 3. And then next, our x term is what?
7.
Positive 7. And then the last term is positive 3. Okay, so the very first one, we just do what? We just bring it straight down. See, straight down and the plus sign, right? So we just bring this down, and that's 4. The next time we're going sideways, which means to do what again?
Multiply.
Multiply. So 3 times 4 is
12.
12. And now we're adding down. -3 plus 12. 9. Okay? You're adding down. And now we're multiplying sideways again. We're going to the next place. So 3 times 9, which is 27. And maybe it helps to go ahead and put the pluses in it. There we go. All right, so you know it's either positive or negative. So we add these down. Positive 34. Multiply again. We get 102. And then we add down again and we get 105. Now, what do I fill in here? What goes with the 4? Since the first
X
term had been an
squared.
x cubed, the first term in our answer will be x squared.
X squared.
Good. X squared. X, nothing. And then this is the remainder right there. Okay. So the easiest way to work on these is going to be probably to watch that YouTube video and like follow through it. And if you need to remember how to do it. Some of you, it sounds like y'all have seen this before. What this becomes really useful for, y'all are gonna love this. In a year or two, you're gonna have problems that maybe have like x to the 4th plus 3, x squared plus 6x plus 15. Okay? There we go. So what can I factor out? What can I divide that by? Okay, and so the way you find that is because this has how many, this tells you right here, no, this wouldn't be a, there we go. So this tells you right here, there's how many different answers for X? 4. There's 4 answers for X, okay? So what we did here from that problem was we found one, we didn't find one of the answers because there shouldn't be a remainder. If it was to work out correctly, it would divide evenly. Okay, but in reality, we did divide it by X minus 3. So basically we're saying this, if I multiplied it back, if we went back to Ben's lesson on multiplying, if I multiply this all out, I'm gonna go back, get back to the original problem, right?
Yeah.
Okay, so if I do this, and I need to
Don't we have to have a 3?
These
pick
are
something.
your books.
Awesome, thank you so much for bringing them in. There we go.
Your.
My books. My daughter's been so sad that we didn't have that at home. Just kidding, she hasn't. No one actually misses an algebra book, right?
I mean, maybe you, but that's a bad thing to do.
Actually, it really does bug me. Like, I'll know I have, like, say, like, 2 algebra books, and I don't know, or 2 algebra 2 books, and I'll be like, where is the other one? That does drive me crazy, honestly, sometimes. So the idea is that eventually we're going to get to where, so we're kind of having to guess, like, is this a positive 2 or is this a negative 2? And this is the fastest way to get to that answer, is doing it this way. Okay? So that's what you'll use it for eventually, and that's why this method is a little faster. Okay, so that is it for today. So